All right, so I'll do one more proof here. This is number 6 from 7.4. You can find it in your book there. I would actually encourage you to pause the video here and give it a shot yourself in terms of using conditional or indirect proof on this. Give it a shot yourself and then come back and watch the video and see if you did okay on this, all right? But assuming you have done that, I'll go ahead and get started here. We're going to look at the conclusion first to determine if we're going to make this a conditional or an indirect proof. There's no horseshoe in the conclusion at all, so indirect is going to be our best approach. So we indent. We're going to assume the opposite of this conclusion, the opposite of tilde an. Well, now, I mean, it's pretty straightforward here, right? We could assume double tilde an. That would be great, right? That would work perfectly fine. It will end up that we're going to have to do a couple double negation steps along the way. So just to save those steps, we can actually go ahead and assume an, just dropping the single tilde there, which is out at the far left of that statement. We want to get a contradiction. All right? So again, I want to warn you, when there are quantifiers involved in your conclusion, we want to make sure that we're making the proper assumption, and that is just to put a tilde out to the far left of that quantifier. But since there aren't any quantifiers involved with this one, we can go ahead and just drop the tilde here and get an assumption that works for us. Okay. I also want to note here, so we'll look at this assumption. Does this assumption have any free variables in it? It does not, right? It doesn't have any variables in it at all. So we are good to do UG in here if we see fit to do so. Okay, but I like to use my assumption right away. There's AN right there. So this is P horseshoe Q, and P, it's like this particular section 7.4 has been brought to us by modus ponens. We've been doing it so often. But yeah, modus ponens here will give us tilde Bn. I'm going to grab that if I can. Of course, number 1 here is going to come into play, right? We know that. So number 1 has both the A and the B in it. Very important to realize in number 1, the main operator of number 1 is the horseshoe. So these quantifiers will not be coming off. So instead of removing quantifiers from line number 1, we should consider adding on quantifiers down here somewhere in order to get number 1 to work with this stuff. So one way to do this would be to simply look at 1 and 3 here. And all we need to do is add on the existential quantifier to line 3, and we'll be able to work with line 1. So why don't we do that? Right? Remember, you can always do EG. I want to note, if you did try to do this on your own before watching the video, there are multiple correct ways to do this one. Another option is to add on the existential quantifier to line 4 and get there exists an x tilde bx, and then use quantifier negation rule, which will enable you to do a modus tollens with number 1 as well. That's a different route here for this one. At any rate, this works, and now we can do a nice modus ponens to get for all x bx. However you're approaching this one, we know we want to end up with a contradiction, and so we have tilde bn and we have for all x bx. Now, note, you can't do UG on number 4, not because of the new restriction that we learned about in the first video, but because this is not a variable. You can't do UG when you don't have a variable here. So what we want to do instead of adding a universal quantifier to this, to somehow get it to match this or something like this, is we can actually just drop that universal quantifier. And note that when I drop the universal quantifier, I get to choose any letter I like. Well, N works nicely to give me a contradiction with line 4. And so combining, or conjoining, I should say, 7 and 4 gives us this. That is a contradiction. Once we get a contradiction, we unindent, we simply write down our assumption and add a tilde to it. And this is indirect proof, lines 3 through 8. Right? So that works very nicely. Hopefully that's something like what you got. Maybe just because we have a little bit of time here, I can quickly show you here, do an alternative on 5. So 5 is still indented. If we go the other route, instead of doing EG on 3 there, we could do UG, sorry, not UG, but we could do EG, excuse me, on 4. If there exists an x tilde bx, right? So I'm just going to show you the other way to do this one, in case you did it that way. And then, if we want to get it to work with line 1, we simply do QN on 5, like so. And now, with 1 and 6, we have a modus tollens. Giving us that, modus tollens, right, with 1 and 6. What now? Well, let's see if we need to get a contradiction. Here's tilde, there exists an XAX. Here's AN. We could simply do what we did here on line 8. Do EG on line 3, giving us that. And now 7 and 8 combine here on line 9. Right, so that's conjunction. 7 and 8, that is a contradiction. And so now it's one line longer, but we still end up in the same place. Tilde AN by indirect proof, lines 3 through 9. So I just wanted to show you that in case you did it the modus tollens route. So hopefully that's helpful. Either way works perfectly well. I should mention here that when it comes to the proofs on the last exam, right, you will not have to exceed 9 lines on any of the proofs on this last exam if you do them in the shortest possible way. So like, for example, this one would fit that, right? But if you did it this alternative way, and so it goes on to 10 lines, of course, you would not lose any points. This is a perfectly good way to do it. But you wouldn't have to go beyond 9 lines on any proof on the last exam. So let me just share that with you. Okay.